So what
So
they're
no.
teaching now?
Till now they taught us this. Oh yeah, they started tension for us.
What is the last topic?
Sir, till now we have internal assessment. So motion and plane we have to revise. Horizontal projectile motion, oblique projectile motion, everything from vectors. Full chapter we have for this test.
No, when is the
This one
test?
is internal assessment, it seems.
When is the test?
August 1, like
August 1,
2 days later. Yeah,
Saturday.
at the yes.
Okay. What is the portion? Motion in the plane?
Motion in a plane, full chapter.
Newton laws of motion?
No, that's not that. Motion in a
Okay,
plane, the complete chapter.
fine. So any difficult, your marks are less,
Yeah,
right?
this time I got 61 yes.
So you can do one thing, same test, you attempt the test again in 1 hour or
Yeah,
something.
yeah.
Okay. And you should get
Uh,
more marks, hopefully 100%, and then see where you are going wrong. Not now, we can try later.
the question paper.
Yeah. I think we have discussed a little bit.
Yeah, a lot actually.
Okay, so don't look at the question paper now. I think we've already seen it. So just attempt the question in 1 hour or something, and then see how much you're scoring.
Okay, sir.
So what you want to discuss now? Which
We
concept?
discuss about circular motion. Circular motion, the complete thing. Uniform, non-uniform, everything.
Non-uniform comes in Newton laws of motion, right?
Yeah, so circular motions.
No, circular motion, there are two things. One is horizontal circular motion, conical pendulum, they are uniform. Okay, uniform in the sense speed is uniform.
Yeah,
Vertical circular motion is non-uniform because speed is zero at the turning point.
it comes under. Just a minute, sir. I'm seeing linear. Linear circular motion. It comes under
There is nothing. What is linear?
vertical. Sorry,
Huh.
vertical circular motion is.
Vertical circular motion is simple pendulum.
Yeah. So non-uniform circular motion comes under that.
Yeah. Why is it non-uniform?
And last time I lost mostly in circular motion only. I didn't have time to study that.
No, the vertical circular motion. Why is it non-uniform?
Due to changing energies, like it loses some sort of energy during one swing.
Speed is
The
decreasing
pendulum
now.
example. Yeah.
Speed is decreasing as it goes up.
Yes.
And
Yeah.
horizontal circular motion speed is constant.
Yes.
Only the direction is changing.
Yeah. Okay. Okay, we
You
can
know
start.
angular acceleration? That concept is there or no?
Angular acceleration, sir, but I don't know that.
Yeah. So it's increasing. Say acceleration was increasing velocity, right? Angular
Yeah.
acceleration is increasing angular velocity.
Yeah.
The linear acceleration is the increase in velocity. So I can say final velocity minus the initial velocity and the amount of time taken for this increase, delta t. Okay, since delta t is a finite time interval, so this acceleration is like an average acceleration. Okay, if it's instantaneous acceleration, the time interval is very small.
Okay.
This will be dt. B final means B initial. Similarly, I can define angular acceleration. The symbol is alpha. Is half hour the angular velocity is increasing. So omega final minus omega initial by delta t is average and dt is instantaneous angular acceleration. Uh, to try this question,
Yeah. Circular bar radius 1.5 meter. The constant angular acceleration.
straightforward question. What is the answer? What is omega 2? How do you do it? Definition of omega. Sorry, definition of alpha. What is the time interval between these two? 1 second, 2 seconds, 3 seconds.
Yeah.
How much is the time interval?
Time interval is delta t by delta t. 2 seconds. The time interval is 2 seconds. They are given at the normal acceleration at the instant of 2 seconds. So it's W2 minus W.
Get the answer.
Yeah. Sir, 120. 2 pi plus t, no, sir.
You make
So
this a
pi
mistake.
will get cancelled. 120 plus t.
So
120 plus 4.
there is a mistake here.
124 is right though.
It's per minute, no.
Okay, so per second we have to find. So we have to convert it into per second, sir.
Yeah.
So after we convert it into RPS, will be like
Not RPS, radian per second. Is it clear?
yeah,
Per minute is some value. Per second will be less than that. Okay. So and the factor is 1 by 60. To avoid the mistakes. Per minute something means per second will be less than that. Okay. And the factor is 60. So it is 1 by 60. What is angular displacement?
in
See,
terms of
another thing
angular
is,
displacement.
so another thing is it's a constant acceleration. So similar to linear motion, is equal to ut plus half a t square, we have theta equal to
Okay. What is the theta value, sir?
theta value initially, if the thing is given, we'll use that.
Okay. And after that, initial theta value, what they are given till now?
Ut plus half a t square, so omega naught t plus half alpha t square. Okay. Another thing is we can also use v square equal to omega 2 square equal to omega 1 square plus 2 alpha theta between the interval 0 to 2. Okay, so this we can use because velocity is known. Omega 2 square is 6 square.
Yeah,
So these equations are valid for acceleration being a number, that is it's uniform and constant. There is a constant angular acceleration. Okay, that's why
yeah,
it's valid. Otherwise, it's not
yeah.
valid.
Okay, so that it works like that. Okay. So if it's
Angular
theta,
displacement.
then angular displacement is acceleration by time.
Omega 2 square is 6 square. Don't skip
Yeah,
the steps.
yeah. Omega square is you got omega initial plus 2 alpha theta, which is equal
Omega
to
2
6 square.
square.
Omega 2 square. Yeah.
Omega 1 is
2 rad per seconds, right?
2.
2 rad per second square. 6 square, sorry, 6 square.
Thirty six minus 4. 32 by 4. So 8 radians.
30 to 8 radians. Linear velocity we have to find now.
At t equal to 2 seconds. And the relation between linear angular velocity is v equal to omega into r. P and omega, the relation is v equal to omega into r. This we have to find at 2 seconds. Okay, so omega at 2 seconds is 6 into radius is 1.5. 1.5 is nothing but 3 by 2. So 9 meter per second. Nine meter per second. And then tangential acceleration, which is alpha into r. Alpha, relation between angle A and alpha is alpha into r. The relation between V and omega is V equal to omega into r. This acceleration is tangential acceleration. This was a tangential velocity because velocity is only tangential. There is no radial velocity. Radial velocity is zero. Okay, but acceleration has got both tangential component and the radial component. Radial component or the perpendicular acceleration is how much? V square by r. The centrifugal acceleration or centripetal acceleration. Okay.
Okay.
Tangential acceleration is circular acceleration or circular motion acceleration, which is alpha into r. So alpha is 2. This is 3 by 2, so it's 3.
Okay.
Tangential acceleration is 3. Okay. And normal acceleration is v square by r, which is same as omega square r.
Omega 2 equal to 6 radians and r is equal to 1.5 radians. We can get 6
That is
into
fine.
1.5.
Let's get this formula correct. V square by r is same as omega square r.
36 into 1.5. Five, 54.
V is omega into r, so it'll become omega square r.
R.
This you have to remember. Normal acceleration or perpendicular acceleration. Tangential acceleration is related to the angular velocity or angular acceleration. Like this. Understood?
Yeah, yes, sir.
Anything else you have to find out? Normal acceleration is this one. Okay, fine. It's 54. Next one, a particle is moving in a circular orbit.
Yeah.
Constant tangential acceleration after 2 seconds. Right? Tangential acceleration is 80, which is equal to alpha into r. And this is constant. So, and r is a constant. So alpha is also constant.
Angular acceleration. Now the angular acceleration is omega square r.
So let me see, this is the starting point, horizontal. There is a t equal to 0. There is a position.
R becomes 45 or 45 degrees.
45 degrees. Degrees
So like the radius becomes an angle. So alpha is equal to 45. Then radius is equal to what is the radius equal to again, sir? Sir?
Yeah. It should be given.
It isn't. They have given like angle between the total acceleration and radius is 45. Not about the radius though.
Angular acceleration is alpha, no? So you don't need the radius then. you have to find out this one alpha. Tangential acceleration is yeah, from that you can find alpha, no? Alpha is the angle covered by, wait,
Yeah. I was just charging
total
device.
acceleration. No,
Battery
no.
was kind of low.
Total acceleration and R is 45, not total acceleration is tangential moment only. So this is the figure, not this one. Okay. What is the acceleration per particle?
Yeah.
So when it is 45 means then uh, the radial acceleration and the tangential acceleration are equal magnitude wise. What will be 45? No, because if I add these two, radial acceleration and tangential acceleration, if the sum is between them, these are equal vectors.
Yeah.
Okay, so that means the magnitude of this thing is same. And perpendicular action, I know the value. It's v square by r, which is same as omega square r. And tangential acceleration is alpha into r. So alpha is omega square.
Okay, I'm doing. This part I'm doubtful about
So
the angular acceleration thing.
omega should be known. So this also follows this 90 degrees. So this is 90. So this is 90.
Yeah. So like in terms of that angular acceleration,
Alpha equal omega square. Okay.
0.5 rate per second angular acceleration calculate.
The second one is it starts from rest, is it? From the beginning of motion. So he is saying it's starting from rest. So 2 seconds, omega is 2 alpha. So if you put 2 alpha here, omega, so from there you get alpha is 0.25 square. So that is one thing that's not clear. He's saying it's starting from rest. So after 2 seconds from the beginning. So what it means by the beginning is it's starting from rest. Okay, so omega naught is 0 and omega at that final time is 2 alpha. So at t equal to 2, at this particular instant, omega is 2 alpha.
Yeah. Yes, sir.
So 2 alpha square
So
equal to
2
alpha.
alphas,
So 4 alpha equal to 1. So alpha is 1 by 4.
which is 0.25 rate per second.
Yeah. So since he says the total acceleration is 45 degrees, that means it's between the angle between the Tangential acceleration, normal acceleration 90 degrees. Okay, and this resultant is 145. So it's between. That means the magnitude of tangential acceleration and normal acceleration are same. They are equal. So that means v square by r, which is omega square equal to alpha into r. From there I get this relation alpha equal to omega square. And if I apply, this is true at 2 seconds. So 2 seconds omega is omega naught plus alpha into t. Omega naught is 0 and alpha is alpha into t. So alpha into 2. So from this alpha is 1 by 4. Clear? So any difficult questions are there in your exercise book in circular motion? Try this one.
Okay, sir. We have to differentiate this one.
Yeah.
3t square minus 60 plus 4. T value we have to find out.
When you differentiate, what do you get? Omega. So omega 4 minus omega 2 by the time interval. Angular acceleration alpha is omega at 4 seconds minus omega at 2 seconds by the time interval. What is the time interval? What the answer?
Mostly still doing. Is it 4?
No.
No, like the omega 2. The omega
Yeah.
2 value.
Omega 4.
Omega 2, 4. Omega and also 4. 12 radians per second square,
Omega 4 is
sir.
28. 4
Yeah.
times 7.
Okay, 28. The radius I forgot to multiply.
What is alpha?
Alpha value 12 radians per second square.
Yeah. And this acceleration, angular acceleration is called average. Why is it called average? Why is it called average acceleration? Because time interval is here is finite, no? 2 seconds. If it is dt, then it will be instantaneous. Okay,
Yeah.
clear?
Yes, another one.
Try this one. Understood the question?
Yeah. I'm doing.
See, the particle is
Circular
here
motion.
at t equal to 0. And the
Yeah.
corresponding omega is 0 because starting from distance. The stopwatch is starting at some time t1. Okay. At the end of 4th second, the time will be t1 plus 4. Okay. So the angle covered between these two times is how much? How much is the angle? It's given in the question. 120 radians.
Okay. So 120 t equal to 0. omega equal to 0. Alpha is given as 3.0 into 10, 3.0 by rate per second square. Angle 120.
Which angle you have to see? So this angle theta 1, you have to find out.
Eight seconds, sir. T1 is equal to 8 seconds.
Eight seconds, but that's it, is it? You don't have to find theta 1.
You don't have to find theta. They only asked how long it is. So 8 seconds is enough.
Yeah. And so in case they have asked how long, then theta 1 is ut plus half 80 square. U is 0 because starting from rest. So just half 80 square, which is half alpha square. I made a mistake here. Half alpha t square only. So half alpha is half 3 into t square is 64.